What if the moon wasn't what we've always believed? What if it wasn't just a simple natural satellite, but the greatest mystery hanging above our heads? What if a clue to something unknown has always been right before us, obvious yet still misunderstood? We have observed it for millennia, yet the moon continues to challenge our understanding. Why is it so large compared to the Earth? Why does it always show us the same face as if it were an artificial satellite aimed at us? Why does its distance allow perfect eclipses, as if it had been placed with such precision that some have wondered, is it just the result of an incredible cosmic coincidence? What do we truly know about the moon, and what remains undisclosed? In this investigation, we'll review data, anomalies, legends, and theories that make the moon perhaps the sky's greatest enigma. But before we begin this journey to the limits of human knowledge, we invite you to support our work. Subscribe to the channel, leave a like, and comment with your opinion. For you, it's a small gesture, but for us, it's vital for continuing our investigations and helping the channel grow. The moon has always been our silent companion hanging in the night sky. We've been watching it for thousands of years, yet its presence remains a mystery that defies astronomical logic. The first thing that stands out is its size. The moon has a diameter of 3,474 kilometers, about 27% of Earth's diameter, and a mass equal to 1.2% of Earth's mass. It's a unique ratio in the solar system. No other rocky planet has a satellite with similar proportions. Mars's moons, Phobos and Deimos, are little more than captured asteroids. Ganymede and Titan, although among the largest moons, are tiny compared to the gas giants they orbit. This fact has led some scientists to see the Earth-Moon system as something different from a classic planet-satellite system. As early as the 19th century, George Howard Darwin, son of the famous Charles Darwin, observed that the size of the moon made the traditional definition of a natural satellite inadequate. In 1977, the astronomer Stephen Peale, in an article published in the Annual Review of Astronomy and Astrophysics, wrote that the Earth-Moon system has characteristics that make it comparable to a binary system, and one fact seems to confirm it. The Earth-Moon system's barycenter, the point both orbit, isn't at Earth's center, but about 1,700 kilometers below its surface. So Earth isn't stationary. It wobbles and moves with the moon around their shared center. And then there's the matter of distance. The moon averages 384,000 kilometers from Earth. This distance makes its apparent diameter in the sky almost the same as the sun's. During a total eclipse, the moon precisely covers the sun, leaving the solar corona visible as a bright ring, a spectacular, unique phenomenon made possible by a mathematical ratio. The sun is about 400 times larger than the moon, but it is also 400 times farther away. This alignment is only temporary. The moon is actually moving away from Earth at nearly 4 centimeters per year. Perfect total eclipses have only been possible for about 500 million years, and will stop in another 500 million years. But it's also true that all of this is happening in our time, a time when we are here and able to observe it. David Greenspoon, a National Aeronautics and Space Administration astrobiologist, calls this coincidence one of the most unlikely and extraordinary events seen in a planetary system's life cycle in his book Lonely Planets. But it's not only the size or distance that raises questions. There's its orbit. The moon follows an almost perfectly circular orbit with an eccentricity of just 0.055. This is a strange fact because natural moons tend to have more elliptical orbits shaped by gravitational interactions and the chaotic remnants of the solar system's formation. The moon's rotation is also synchronized. It always shows us the same face. This is what science calls synchronous rotation, the result of tidal forces that have slowed its rotation until it became locked. As a result, our satellite seems like a motionless guardian, with one side always hidden from view until space probes arrived. There are many coincidences. A moon that's too big, perfect in its orbit, too precise in its alignment for eclipses, a satellite apparently placed for a purpose. Is it really just a coincidence? Or is the moon part of a design that still escapes us? But these are just the first anomalies, because the mystery has only just begun? If the size and distance of the moon are already enough to raise questions, what science has observed about our satellite has added another layer of mystery. Because the moon is not only large and close, it is also a celestial body that behaves in ways that for decades have fueled questions and controversial hypotheses. The first surprising fact comes from the Apollo missions, when the astronauts dropped modules and components of the missions onto the lunar surface. The seismometers installed on the moon recorded an unexpected phenomenon. The moon resonated for minutes. In one case, after the controlled impact of the Apollo 12 module, the vibrations lasted for over an hour. Maurice Ewing, the geophysicist who supervised the experiment, stated it clearly in the mission report.
"We never expected such a response. The moon rang like a bell for over an hour."
The official explanation refers to the moon's dry and rigid composition, lacking water, which transmits seismic waves much more efficiently than Earth. Yet the magnitude and duration of the phenomenon left even the mission scientists astonished. Such extreme behavior, though theoretically explainable, is unique in our experience with planetary seismic exploration. And it led some researchers to wonder whether the moon was hollow inside or at least had enormous caverns. Additionally, the craters have long linked popular storytelling and science. The lunar surface is actually marked by billions of years of impacts. Observing the craters, you notice the largest ones aren't as deep as you'd expect if depth grew with diameter. But this is not a mystery without explanation. Small craters, up to a few kilometers in diameter, keep a simple bowl shape, with depths well proportioned to their diameter. Large craters, on the other hand, collapse under their own weight, forming terraces, central peaks, and slumped walls. As a result, the depth grows more slowly than the diameter. Yet this explanation, although physically correct, did not convince everyone. As early as the 1970s, two scientists from the Soviet Academy, Vasin and Sherbakov, proposed a radically different interpretation. In 1970, in the magazine Sputnik, they asked themselves, what if the ratio between crater diameter and depth wasn't just from gravitational collapse, but hinted at something extraordinary? If the moon concealed an inner shell, an armored layer capable of stopping impacts beyond a certain limit, the result would be exactly what we observe: wide but shallow craters. An extreme hypothesis, of course, but one that was linked to a series of other oddities. The first of these oddities concerns the very composition of the moon. If the hypothesis of an artificial structure seems crazy, the data from the lunar rocks brought back to Earth make it, for some, disturbingly plausible. These rocks have actually revealed unusual concentrations of extremely resistant metals, particularly titanium and chromium, in percentages far higher than what one would expect from a celestial body of this kind. To understand the anomaly, let's think about titanium. On Earth, it's a strategic metal essential for the aerospace industry. We use it to build military jets, submarines, and spacecraft because of its great heat and corrosion resistance, along with its surprising lightness. Now imagine the scientists' astonishment when analyses such as those documented by Korotev in the Journal of Geophysical Research showed that certain areas of the moon contain 10 times more titanium than the richest terrestrial rocks of this element. For Vasin and Sherbakov, this was no coincidence. It was the smoking gun. In their theory, a protective shell built by an advanced civilization would have required exactly such a material. The surface abundance of titanium would just be residue from the inner shell, brought up and spread by billions of years of meteorite impacts. However, these unusual metals aren't the only strange aspect of the moon's outer shell. Its very structure, the crust, hides a geographical paradox. It's thicker on the far side, the one we never see, a fact that defies logic. In fact, one would expect that Earth's gravity over time would have thinned the crust on the side that's closer. Instead, exactly the opposite happens. We have an unusual composition and asymmetric structure, but the lunar surface hides another kind of secret, not carved into matter, but in a phantom energy, magnetism. The moon is considered a magnetically dead body, lacking a global field like Earth's. Yet its surface tells another story. There are magnetic scars, areas of strong, localized magnetism, inexplicable fossil remains of an ancient magnetic field. The most unsettling thing is these anomalies are often tied to enigmatic formations. Lunar vortices, or lunar swirls, appear as bright, sinuous patterns on the dark dust, almost as if they were painted. The theory is that these local magnetic shields have protected that soil from the solar wind for billions of years. But what generated these very specific magnetic shields, and why do they create these almost artistic shapes? Are they the ghost of an ancient active core or the trace of still unknown events? From the traces left on its surface to the secrets of its internal structure, the moon reveals itself as a body full of contradictions. But if we broaden our view and observe not just the object, but its cosmic dance, perhaps the most puzzling anomaly of all emerges: its orbital behavior. The moon, as we mentioned earlier, follows an almost perfectly circular orbit. Someone might argue that other moons in the solar system also have similar orbits, like those of Jupiter, but there's a huge difference. Jupiter's moons formed in a stable setting, while the moon likely originated from a catastrophic impact. Models have trouble replicating how such a violent event resulted in a stable orbit. It's as if from total chaos, an almost perfect order emerged. But it's not just the orbit that's surprising. It's the combination of this orbit with another behavior, synchronous rotation. The moon always shows the same face to us. Science explains it as the natural result of tidal forces. Yet the final outcome is unsettling. Let's think about it. What do we do when we design our artificial satellites for telecommunications, Earth observation, or spying? We place them in a stable circular orbit to keep a constant distance. And we orient them so that their instruments and antennas always point toward the Earth. The moon does exactly the same thing, a circular orbit, and one face is always pointed toward us. A behavior that, in a natural context, has inevitably led some to wonder, is it just a coincidence, or are we observing the characteristics of a gigantic observation instrument? The moon is so present in our sky that it seems eternal, yet there are ancient stories that tell us of a time when the moon was not there. A time when the night sky was different, darker, deeper. A time that human memory, through myths, may not have entirely forgotten. These stories emerge from peoples and cultures distant from each other, both in space and in time. Philosophers like Aristotle and Apollonius Rhodius recall people who lived before the moon. Aristotle describes the Pelagians as an ancient people who lived in Arcadia before the moon appeared. Plutarch and Lucius Annaeus Seneca mention remote times when the night sky did not know the brightness of our satellite. Beyond the Mediterranean, in pre-Columbian America, oral traditions of some Andean peoples, such as the Quechua and the Aymara, tell of times when the night was without the light of the moon, an era that preceded the arrival of Inti the sun and Quilla the moon. In Mesopotamia, the birthplace of ancient astronomy, mythological texts describe the firmament as once incomplete. The Sumerians and Akkadians, who closely observed the sky, mention a time when the heavens were different before the gods arranged the celestial spheres. They are legends, of course, but why would such different peoples have told the same story? Could these stories be distorted memories of a real event, or symbols of a major historical shift for early civilizations. Science does not claim the moon appeared only in historical times. Astronomical and geological models date its formation to about 4.5 billion years ago. But the fact remains that these traditions exist and that over the centuries, they have fueled hypotheses and theories that see the moon as an object that arrived later, perhaps brought, perhaps placed. In 1909, the British scholar George Frederick Chambers collected several of these traditions and observed how the theme of a time without the moon was surprisingly recurrent in the mythologies of the world. And what's even more surprising is that these legends don't seem to be explainable by known astronomical observations, such as eclipses or temporary absences of the moon in the sky. The mystery deepens because these stories, echoes of a very distant past, pose a different question for us. Why did cultures so far apart feel the need to imagine a sky without its brightest guardian? What deep collective memory, real or symbolic, were they trying to preserve? Faced with such a dense mystery, science did not stand by and watch. It built an impressive narrative to explain the birth of our celestial companion, the giant impact, the OR. The scenario it describes is apocalyptic. About 4.5 billion years ago, a planet the size of Mars, called Theia, crashed into a still young Earth. The impact is catastrophic. A huge cloud of incandescent debris is thrown into space, and over thousands of years, it comes together to form the moon. This theory on paper is elegant. It would explain why the moon has such a small iron core and why it is so large compared to Earth. But when we put this story to the test, when we compare it with the anomalies we've seen, the verdict becomes uncertain and full of doubts. The first doubt, perhaps the most puzzling, concerns its identity. Remember the unusually high titanium concentrations unlike those on Earth? Paradoxically, when scientists analyze not the quantity, but the fingerprint of those elements, their isotopic signature, they discovered that it is identical to that of Earth. If the moon were made half of Theia, it should have a different chemical DNA. But that's not the case. As explained in a study in Nature Geoscience, it's as if two different people had identical fingerprints. A paradox that forces models to assume either perfect mixing or extremely unlikely coincidences. And what about its strangely circular and stable orbit? The official theory explains it as the result of billions of years of gravitational braking. Yet, as astronomers like Tuma and Wisdom observe, bringing such perfect order out of the chaos of a catastrophic impact requires very specific initial conditions, a series of fortunate coincidences that almost sound forced. We've explored scientific data, ancient legends, and bold hypotheses, viewing the moon through both scientific and skeptical eyes. And now, at the end of this journey, the mystery not only remains, but becomes deeper, more personal. It's no longer about one anomaly or misplaced data, but about a series of improbabilities, an intricate pattern of coincidences that challenge our idea of chance. The giant impact theory gives us an origin story, but it doesn't explain the reason for this pattern, this almost unsettling perfection. And this is where the most radical question arises. What if the key isn't to analyze each anomaly individually, but to look at the final result? What do we see? We see an object that doesn't behave like the chaotic residue of a collision, but like a high-precision instrument. Its stable and circular orbit, combined with its rotation that is perpetually locked, facing us, is no longer just an astronomical oddity. It serves as a model for how we build systems to observe, monitor, or influence a planet. And here the mystery becomes dizzying, because this machine, seemingly perfect, is not just there, inert. It seems to play an active, almost providential role. Its dance with the sun creates mathematically beautiful eclipses. Its presence stabilizes Earth's axis, creating a predictable climate where complex life can flourish. The next time you look up at the sky, don't just see a light in the night. Ask yourself what you're really looking at. A natural satellite, or the greatest and most silent secret in human history, forever suspended above our heads. If you enjoyed this investigation, don't forget to subscribe to the channel, leave a like, and write your opinion in the comments, because it's essential to support our work and to help us grow and spread the channel. See you in the next story.